So this is the opportunity for questions and answers. So you've got the Q&A box on the right-hand side on your screen there. Please ask as many difficult questions as you can. If you've got a particular slide number or something like that, please type it in there and I can zoom in and jump around to it. This is your time now, your opportunity. Okay, so we've got a few questions there. Let's see what I can. Oh, hang on. What have I done? Questions. Right. Thanks for the session. You're most welcome. It's been a genuine pleasure. Okay, so got a lot of people on today. It's great to see you all. Okay, I can hear. Okay, yes. Right, neither captain. Hi, Steve, Lily, good to see you. Neither captain or first officer recognised or challenged the non-standard controller clearance. A missing control action, yes. Well, logically, it is a missing control action that they did not challenge the control action. But we have to be cautious about bias. And what I mean is they themselves may not have known that it was a non-standard clearance, and because of that would not have had a challenging control action. You would logically say they should do, but again that raises questions about whether the crew on the flight deck had the necessary training and qualifications, whether they were, performing appropriately, or whether they were just, laissez-faire approach on that particular day. So it would be interesting to look at them, look at the flight deck data recorder if it's available, and then also look at the interactions with their airline operator and possibly their training and currency checks. Thanks for that, Steve. Next one. Okay, so if GLEA crew didn't hear P8 Sol's landing clearance and runway 22 was also open, they could have assumed that P8 Sol was cleared to runway 22 and not 24. Oops, meant 24 then 22. Right, okay. Well, okay, so one of the standard mitigations is, and I'll go back to the control structure picture with the radios highlighted. So one of the standard mitigations is that the aircrew will have a watching brief on the radios, because if they can hear somebody talking on the radio, that gives them a mental model, situational awareness of what's going on around them. Now, we do know that there was a 20-second delay before the aircraft captain receiving the radio frequency for the runway controller. So potentially in that 20-second window, the runway controller was talking to P8 Sol and GLEA missed the opportunity because of that delayed control action. Now, it may be also that during the period that they were on the frequency with the runway controller, that the runway controller was dealing with other aircraft and P8 Sol had already been given the clearance. Or it may be something else going on the flight deck that the aircrew just didn't hear it, for example. That is always one of the aspects. And that's why one of the recommendations is to go and investigate or establish what the sequence of these events were in terms of the ground controller sending the instruction to change frequencies to GLEA's captain, and then when the P8 Sol aircraft received the instruction to land, the clearance to land. Okay, so let's have a look. Yes, does a ground controller ever give permission to flight captains to enter a runway? Doesn't the pilot know that only the runway controller gives that permission? Joanna, that is a cracking question. So does a ground controller ever give permission to captains to enter a runway, and doesn't the pilot know that only the runway controller gives the permission? That's a very good question. So there's two aspects to that. The first is that the pilot's mental model may be that they have no idea what the airport air traffic control structure is. They may not even know that there is a different, if they've operated at a small airfield, the role of the ground controller, the runway controller, all of these other things may be performed by one person, and they don't differentiate that control structure. Whereas at a busy airport like this, they will have distinct people doing those distinct roles, but the control structure will be different. In the first instance, there'll be one air traffic controller with lots of interactions, doing lots of responsibilities, whereas in this instance, they're separated out. Now, the pilots may have no knowledge of that. They may have assumed, and I'm postulating, they may have assumed that the ground controller did give them clearance to go on the runway, and they didn't realise that it was separated out and that they must get permission from the runway controller. So you're absolutely right. That's a valid point that in terms of the further investigation that I recommended, you'd need to go and find that out, understand, what was the pilot's mental model of that. But also, that raises an important point from a global perspective. Is there a safety constraint? And there is. But how is that safety constraint enforced globally that the aircrew must have a mental model of how that particular airport air traffic control structure is implemented? Because even at one airport, I'm aware that the air traffic control structure, the control structure varies from shift to shift, maybe even changes overnight. At night time, when there's not that much traffic, perhaps there is only one runway controller and ground controller doing the job. But during busy hours, maybe there's two. And this was a relatively small aircraft, so they may not necessarily be that used to operating in that environment. They may just presume that they've got clearance. But it's a very, very good point, that. Okay, everyone's going crazy with questions now. I hope I can answer them. Right, so where were we? So thanks, Joanna. That's a really good question, very good question. But as I say, when you do the investigation, you can establish what the mental model was of the aircrew. Is that why they carried on without a clearance? Is that why they didn't question, hey, I need clearance from the runway controller? Because it may be that that was the case. And that doesn't mean that they've failed, if you like, Right, okay, so what's the best reference for how to do such an analysis and case studies like you have done here? I'll be honest, there aren't that many in the public domain. The ones I've used to help me learn and practice is obviously Professor Levison's book, Engineering a Safer World. She has a chapter in there all about CAST. She describes the CAST method in 9 steps. I kind of describe it in 3 or 4 to make it a bit easier to get your head around. There is a good example done by a chap called Paul Nelson. Now, Paul is a pilot who did his master's dissertation at Lund University, I think it was. And if you type online CAST accident analysis, let's have a think. What was the accident called? Basically, the accident he analysed as part of his master's dissertation was an aircraft taking off on the wrong runway. And unfortunately, they took off on a short runway, and I think there was only one survivor who was one of the aircrew. And that's one of the better examples that are available. But unfortunately, there aren't that many. I mean, you're welcome to use this one when I make it available, and I'm happy to talk about it and, give you some support if that's what you'd like. Great job, Simon. Points out the necessity for exhaustive research of existing versus required safety constraints. Can't afford to miss one. You're absolutely right, Steve, and thank you for that. Yeah, so just to highlight the point, so I made it earlier on. If you have an incident, if something happens that is not what you wanted, then it indicates, alarm bells should be ringing. There's something wrong with the control structure, and we need to go and look at it. Because if we don't look at it, we might end up having a big accident, in the future. And for me personally, when you have an incident, it's a cheap opportunity to have a look at what's going on, what's going wrong, but what's also going right that's dangerous and potentially sensitive, to disturbances. Okay, Simon, I've enjoyed your example and I like the ability to examine the detail of the safety system as you've demonstrated, but who do you think would employ this tool in a practical aviation organisation, and how much training is needed in STAMP to employ this? Okay, well, let me just wind that back. So thanks, that's a good question, Mark. So who do you think would employ this tool in an aviation organisation? Well, looking at this control, in fact, so this control structure then, so you can see that there are various organisational entities at play here. On the left-hand side, we've got the airline operator with their aircraft and their crews doing the missions that they do. You've got the airport, ATC management, and their staff of air traffic controllers supported by the airport technical equipment. I would argue that any of those organisations could take advantage of this immediately. So if you work for an airline, or if you work for a regulator or an investigation board, or a particular interested party such as a pilot or controller organisation, you guys could take this and analyse your own operations and identify issues. You might identify issues that exist across the interfaces between the different groups, but ultimately looking at it from a systems view, as I've done here, as opposed to from your organisation only, allows you to get more insight and more value. So I'd argue that anybody and everybody could take advantage of this, but it is a systems theory, systems thinking method, so it is about thinking about the big picture. And obviously if you're one of these entities, you will have access to detail that I certainly don't have, but obviously you'll only have what I call an information horizon. So you inside your organisation will have lots of detail about the stuff you do, but the information you have about everybody else will be limited. And I suppose this method sort of prompts people to form a group, an analysis group from these different areas to work together, like I said, as the SMEs, not only to validate the model, but also to understand the subtleties of some of these interactions. Because the power of this method is that it finds the subtle issues that you just don't find as part of the other methods, the other traditional methods. And especially because the traditional methods focus on failures. As you saw here, the pilots of G-Lear, they didn't fail going onto the runway. They had genuine reasons to believe what they were doing was the right thing to do. So this is important. These are important aspects. So, and then finally, how much training is needed in STAMP to employ this? Okay, well, this is a bit of a, as with any method, you have to have a go, you have to practice, you have to share ideas, talk to people, and if you do this on your own, like I've done here, it is a tough thing to do because of all the mental gymnastics you have to do. Because you've got to sort of almost visualize yourself in each one of these positions at each of these jigsaw pieces. Think about the inputs and outputs, the control actions, the sensory feedback, the mental model, how they must have, in the context of where these pilots were sat, what must have the world looked like to them, what made sense to them on the flight deck at the time, but also what makes sense with hindsight, and that's a difficult thing to do. So in answer to the question about how much training you need, I think going through Professor Levison's book, having a look at the webinar on YouTube, having a look at some of the other webinars that I've done, looking at some of the papers like the Paul Nelson master's thesis, I think that's a good one because it's about 20-25 pages and you can get a real feel for it. But ultimately it's about practice. And it's two parts practice. One is getting used to building control structures, playing with jigsaws, and that is a bit of a practice in its own right, because you're thinking differently. You're not thinking about chains of events. You're thinking about structures. You're thinking about relationships. So you need to practice doing modeling, control structure modeling, and then also you need to practice with this method. So as I showed on like this one here, you've got in this case 6 columns. And you essentially go through and fill in the columns identifying specific information from your source information or your experts, but also inferred information. So in the case of some of these safety responsibilities, obviously I've inferred some of these, like, excuse me, let's go back to the pilot one. So, where is it? PH Sol, no, G-Lear aircrew. Okay, so in the case of the captain of G-Lear, I've inferred that they must have some kind of responsibilities associated with operating and commanding the aircraft. Now, it may be that there's some specific things in there that I've missed that really needs to be in there and considered. And picking up on the, are the air crew required to use standard phraseology from document 4444? Because if they're not required to do that, then that suggests that the ICAO documents are not fit for purpose. Or if they are required, then why didn't the airline or operator feed that information into the pilots? You know, so there are questions there. So in answer to your question about how much training is needed, I would say you only need like a basic introduction to stamp course, and then it's really about practicing with examples, because that's it, practice. In the States, all standard control of pilot terminology is printed by the FAA, no deviation is allowed. Excellent. So if this was an American FAA covered investigation report, it would be interesting to know a bit more about why the pilots didn't behave appropriately. Okay, so feedback. Really like the HCS element of the CAST analysis and how efficient it can be in terms of integrating the various controls. Thanks, Mark. Good observation. Swiss cheese or layers of safety can easily be displayed like the stop bar used in low visibility, but as you demonstrated, the interaction, who controls it, can affect its effectiveness. This is a feature that the bow tie would not display efficiently as CAST. That's a brilliant observation, that, Mark. Thank you for highlighting that. So let me just go, well, let's have a look. So on this control structure, I haven't modelled the interactions with the stop bar lights. I've just put some arrows with a question mark. And that's because there is not enough information in the source material to tell me how that important mitigation fits into the system. So as Mark has kindly pointed out, if I did a bow tie analysis of this and I was a runway safety manager or whoever, and I've got my bow tie analysis that says, yeah, we've got some stop bar red lights, that might look like it's a valid mitigation, but clearly in this scenario it's not. And in this scenario, the reason for that is because the procedures for using the stop bar red lights stipulated that they should only be used during restricted visibility. And clearly there's a mitigation there that could have benefited a day when the visibility was not restricted. So let me just pick that up what Mark said. So where is it? Yeah, this one. So clearly I've got two diagrams that show a clear picture of why one control structure design solution is better than another one. It's just literally a change in where the arrow is. It's that straightforward. You can't get more simple than boxes and arrows. So yeah, that's a good one, that, Mark. Thank you. Shem, hi Shem, good to see you. Sometimes there will be only one controller, or the controller will be working several frequencies depending on demand. Yes. So I'm hoping that observation, if you have one physical person operating as an air traffic controller performing these multiple roles, then the actual control structure on the day that that's happening is more brittle, less resilient, less robust, and more likely to result in a runway incursion than if it was separated out with appropriate interactions. Now obviously if it's a quiet airport, then that one person has an advantage because they know what's going on, but they quickly get saturated with information. I mean, there are a lot of incidents of runway incursion where the controller literally forgot that there was still somebody on the runway. And that happens, you know, pretty much every week. And that's not because the runway controller is an idiot or, you know, not very well trained and needs more training. It's because that individual is put inside a system, a control structure, which is structured to cause the accident, cause the runway incursion. And that's not their fault. You know, they're just doing their job. The fact that they've been put in that hazardous structure is just circumstance. So just to add a bit more to that. So if you looked at one of those case studies and did the control structure, you would see how narrow it was, how much interactions there were, and how many potentially unsafe control actions there were. So you'd know that that architecture is risky. If you wanted to redesign that architecture, you could use the STPA method, which allows you to try different control structure architectures and look at the safety benefits and negatives of either of those. Okay, so moving on a bit more. Had to go, but wanted to say thank you, Simon, for an excellent presentation. You're welcome, John. Thank you for turning up. I really appreciate it. Your support is brilliant. Mark. Hi, Mark. Would it be useful to know what the percentage of control mechanism failures over time to know the priority risks? This methodology seems aimed at taking a single event and make it 100% bulletproof. How would we know if the errors and mistakes may be more common over a large survey of operations? I'm not sure how to answer that. I think I understand where you're coming from, but I'm not sure. I'd like to ask you a bit more about that, but unfortunately the person's gone. Now, once you've documented the control structure, if you've got a real system with real data about how many times, you know, the ground controller makes a mistake or how many times we've had a runway incursion or whatever that data is, you could actually overlay that data on these different parts of the control structure and identify which of those parts is causing you the most trouble. And then you can direct your spend on your safety budget, for example. You know, so if there are issues with people not staying on the right frequency, you could maybe look at that with, use this as an insight into that aspect. Okay, good stuff. Yeah, I think your ideas about the lights under the control of the runway controller is genius. Okay, well thanks, Joanna, I really appreciate that. Even at busy airports at slow times, sometimes the duties are combined. However, here I will be most interested also in the cockpit communications between the captain and the first officer. Yeah, you're absolutely right, Shem. I mean, that is a key bit of information that's not included. So, where is it? Not this one. Right, okay, so there's a couple there. So, recommendation 10, investigate the interactions between and the behaviour of the captain and the ground controller with regards to how the ground controller's interactions came to be enacted by the captain, and then whether investigate the interactions between and the behaviour of the captain and the first officer with regards to how the ground controller's instructions came to be enacted. So was there was there some kind of dynamic going on there? Was there something lost in translation? Was there something else going on? So yeah, you're absolutely right. Okay, Jenny, so thank you. I don't see the hierarchy of controls is followed for this. Interaction by the airport, eliminate the interaction. Are separate runways for in and out not possible? This task is reliant on communication, awareness and following standard operating procedure, all low on the hierarchy of safety. Controls are expected to be partially ineffective, hence their position on the hierarchy of safety. Jenny, that is a cracking observation. Absolutely. So, what we've done here is we've made explicit the hierarchical control structure. And once you see it in its boxes and arrows form, you can start to understand how robust some of those mitigations, some of those controls actually are. And one example I gave was radio equipment. Now, at a quiet airport or where it's not very busy, so long as the radio works fine and there's no issues with interference and people standing on the transmitting button, then it should be fine. But when you start to scale up the amount of traffic, the number of communications that need to happen, the length and complexity of the communications, that part of the control structure starts to look a little bit flimsy. And it's, you know, by making the control structure explicit like this, it allows everybody to see whether the control structure is actually robust or not. And then you can start to ask questions about the design of it. Well, is it really appropriate for a complicated, busy airport to be using radio communications with its inherent weaknesses for such a safety critical operation? I mean, if we're really serious about runway incursion, you know, and preventing another Tenerife, then should we really be operating in this way with these technologies? You know, on the railway, you would say no chance. You know, we're going to have a level crossing with some barriers, some light, bells and whistles. Obviously, you've got to think about the practicalities of that. But obviously, when you start looking at it in terms of the control structure, you can start asking those design questions and using design, safety-guided design, to either eliminate or minimize these opportunities for accidents, not just get people more training or make them try harder. I really like that. Okay, so yes, Robert Roger. Hi Robert. With three-way communication, should not have at least one of the captain and ground controller have picked up on non-standard instruction? That's a very good question. We won't know because the investigation didn't look at that in that detail, but that is one of the recommendations, as I mentioned to Shem's question. You know, really we needed to know that. We needed to understand what the dynamics of that interaction was and whether it was missed or whether it was detected or whether it was, you know, they weren't acting as appropriately as they perhaps should be. But that shows, you know, when your guard's down, maybe, I don't know. Okay, Mark. Hi, Mark. Incident-related question. Recommended practices for aircrew in using the radio equipment, tune ground and tower, transmitting and receiving on ground frequency while in receiving mode for the tower frequency simultaneously. An argument could be crew obstructed themselves from the broadcast knowledge on the tower frequency. Yes, Mark, that's a very good question, but my counter is, and this is an aspect I was looking at before Christmas about runway incursions with vehicles. So sometimes if you're driving an airfield vehicle, you're expected to have the ground controller's frequency communications on the radio, the runway frequency, and also your mission frequency. So if you're doing bird control or something like that. Now, trying to drive a car on a runway, trying to spot whatever they're trying to spot, whilst monitoring 3 different radio channels and, you know, for safety-related information is just too much for one person. So if you drew the control structure, it would be one controller with lots of feedback into it. And, you know, humans are not superhuman, they're humans, and we should design the system, we should structure the system to recognize that. And trying to overwhelm them and give them too much feedback to deal with is just, well, it's just nonsense. And as I said earlier on, when you draw the control structure, you can see whether, you know, an individual has too much to deal with by all the different feedback that goes into them. Okay, so is it possible to share your list of recommendations? Yes, it is. There are, obviously when you play the replay, you can pause it and read them all. So you can, yes, you can see those, you can have those. I can't say it's a complete list of recommendations, and it would be nice to see what you think, but we'll see about that. How effective do you think CAST would be for malicious accidents in a security incident? Yes, Roger, another brilliant question. Right, okay. So, I'm glad somebody's asked that. That's brilliant. Okay. So this control structure. So we said earlier on that the ground controller issued an unsafe control action, but we don't know whether they knew that they did that and then took action, or whether they were oblivious and just carried on doing whatever they were doing. So we need to investigate that. Now, we know, because the incident occurred, that this control structure was not sufficient to prevent it. Now, if we look at the security aspects, if we had a ground controller that issued the unsafe control action, consciously, then how would we be able to tell the difference between that? And more importantly, how would we have recovered? Because obviously in this incident, we don't know why the control action was issued like that, but we know the result was a runway incursion. So obviously using this method, we can look at both sides of that. We can say, well, is it a conscious thing that was, criminal intent perhaps? Or was it just, one of those things humans do? Now, just going back, just picking up a bit more about security. So you'll notice that the radio equipment, the radio communications, is a critical part to preventing this accident. So if the go-around command had not been sent or received by the aircrew of P-8 then they may well have carried on and landed on top of this aircraft. I mean, we don't know the geometry. We don't know whether P-8 knew that that aircraft was a threat, because that wasn't investigated, or it wasn't documented, should I say. But if that radio transmission was blocked, whether it was malicious or not, or even potentially somebody got on the radio frequency and started spouting commands in proper standard phraseology, how would we know? How would the ATC management or ATC controllers know that that was malicious and prevent it? Do we have those secure features? So, just to sort of round that up, using this method, it doesn't matter whether we're looking at safety or security or cybersecurity. It allows us to see the functional issues that exist and give us an insight in what we can do to resolve them. So it doesn't matter if it's safety or security. But yes, that's a really good question. I like that. Right, so let's have a look. Next one. Hi, Mark, again. Incident-related question. Oh, I talked about that. Shem, the event you are looking for is the stamp analysis of the Lexington, Kentucky Comair 5191 by Paul Nelson. Yes, it is. Thanks, Shem. So those who asked about another good source of cast accidents analysis to have a look at is Paul Nelson's MSc dissertation on the Lexington, Kentucky Comair accident 5191, Comair 5191. If you type that in Google, it's number one on Google. Good answers. Thank you. You're welcome, Mark. Shem again. Hi, Shem. In FAA rules, while they state that they are supposed to be standard, in my experience in worldwide operators, US controllers and pilots are quite sloppy. ICAO PANS DOC 4444 is a requirement in most of the world, yes. Okay. I will disagree with who said that no deviation is allowed, as it is just not true in the US. I raised this very issue at an industry meeting years ago. Some countries are better at standards than others. Germany, for example, is quite good, but even there we see odd things from time to time. Yes, so two points there. It's all right having the ICAO PANS DOC 4444 that says, hey, everybody needs to use standard phraseology. But as you can see on this control structure with the dotted arrows, how does that information find its way through the control structure? Because obviously it's got to be picked up by somebody. It's got to be manifested by, in this case, the airport management or the airline operator. But then how does it get down to the frontline operators? And then the next question is, well, if it does get down to the airport, the air crew and the ATC controllers, why is it not enforced? What is the airport ATC management doing about making sure that this phraseology is enforced? And the same goes for the airline or operator. Because ultimately we've identified that these interactions between the crew and the controllers is fundamental to safety. So, and one way of dealing with that is standardizing the phraseology. But if people are still not using standardized phraseology, then we need to look at how we can enforce that. And being controversial, it might be that perhaps voice communications is not the appropriate method of communicating these safety critical control actions. You know, perhaps it literally should be a red or green light on the dashboard as a silly example. But all I'm saying is when you do the control structure and start to ask these, what are essentially architectural questions, other options for solving the problem can arise, you know. Because it may be that radio comms is just not appropriate anymore for these complex situations, you know. Okay, so moving forward a bit more. So I will do that. Right, okay, so yeah, that's good. Yeah, thank you, Sarah. Shem. Okay, we've got quite a few questions here. Right, that's amazing. Oh, right, okay, so the majority of bow tie development tools available these days allow you to assign responsible owners to controls barriers. You absolutely can identify who owned that control when using the bow tie. That's fine, Mark. When I meant about identifying people who own a particular mitigation, what I mean is in terms of this control structure. So you make explicit who is in control of that barrier, you know, using that language, and what the control actions and unsafe control actions can mean in the context of the wider system. Well, thanks for that, Mark. Okay, so my opinion of the CAST analysis, Mark. Okay, thanks, Mark. Robust and versatile. I can see how it could be adopted to all various industries as it displays a systems point of view. Universe is arguably pretty much a system, and any systems within this system can be modeled with the HCS. Yes, they can, but it will be complicated. My only challenging question is that I can clearly see how CAST is cheap and fast when used by a single soul, but how complex can it get when various safety analysts perform it, and the difficulty that is potentially introduced in integrating all analysis into one. Thank you, Simon, for the webinar. That's great. It's a good question, Mark. Okay, so in terms of practicalities of doing this method, so I did this on my own, solo operation. It was a pain. It was a bit of a mental gymnastics, but that's because, you know, systems thinking is about mental gymnastics and visualization and abstraction. So you have to be quite agile in how you view the world and how you think about it. Now, when you do this analysis as part of a formal operation, like if one of you guys said, I work for an airline, can you come and give us a hand? It will be a case of get the team together, the SMEs who are experienced in these different parts of the control structure, use a particular case study or example, and then start to flesh out the control structure, and then validate that model as an agreed representation, an appropriate representation of reality. Bearing in mind it is a model, and all models are wrong, some are useful, and all of that kind of stuff. So you agree on the model, and once that core model is created, whenever any change is made to the real world, the model also needs to be updated and changed as well. And so long as that model is carefully config controlled and people who interact with it and the analysis that is based upon it is carefully controlled, then there shouldn't be any issues. But it has to be config controlled and looked after. It can't just be willy-nilly, you know, it has to be carefully managed. It is a good point. And then it's about managing change. So managing system change, managing CAST analysis or STP8 analysis change. But obviously, the good thing about this as well is once you've made one of these control structures, if you want to make a change to the system, you can use the control structure as a starting point and do your safety assessment, change assessment, and identify where the issues might arise. And then build the safety requirements into it from day one instead of waiting for a new design and then finding problems with it and then having to live with them because you can't afford to change it. If you've already got the control structure, you can postulate what design solutions you need without spending any money. Thank you, Simon. You're always an inspiration, and I look forward to future webinars. You're most welcome, Joanna. Thanks very much. I really appreciate that. Shem, stop bars are effective for the most part, but it is surprisingly easy to miss them also under certain conditions, perhaps partly because they're still relatively new. It's a good point. That would be about mental models of the aircrew and their control algorithms, as well as external disturbances such as weather conditions, aircraft geometry, all of that good stuff. I've got to go, but this has been really useful, and I shall take it back to the office and pass on the knowledge to the team. Great, thanks. That's exactly what I want. If stop bars were present at every airport, along with the runway status lights systems such as are in place at Paris and a few other airports around the world, yeah. Well, that's from a control structure perspective. So we're talking about airport ATC management and the layers above that. So let me just jump to another picture of the control structure. So here's one I made earlier, as they say, in Blue Peter. Right, where is it? There, not that one. Right, I'll use a complicated one. Right, so please don't be put off by how complicated this is. There is a lot of information there, and I'm hoping that it makes sense. So let's just have a quick look. Right, so this looks really complicated. It's just because there's a lot of information on there. So these higher level controllers above the airport operation. So we've got airline operator, airport ATC management. I've included local regulator, in this case Netherlands government, and then also the pilot airline local regulator, the licensor. So I don't know any information about them, so they're highlighted in purple with some question marks on the interactions. Now, from an ICAO perspective, if there is a standard airport equipment fit, that says your airport shall have these things fitted, one of those standard fit things might be, as Shem pointed out, stop bars and the runway status lights. Now, if you're an airport management and you have not implemented those mitigations, then you might be forced to do it, or it might be optional, and you might be, well, what's our risk budget? Do we want to spend money on that? If you draw the control structure with and without, that will show you what the potential causes of an accident would be and how much benefit getting those things fitted would provide. And I would argue that if the ICAO are not mandating a standard equipment fit across airports, then airport management should be taking the lead, because it's only a matter of time before their airport suffers a runway incursion, and potentially a serious one. So those issues with mandating requirements for airport equipment would be in the high level of the control structure. So if I'd have had time and more information, I could have perhaps gone up the control structure and examined why the airport ATC management did not, on this occasion, have the airport stoplights installed or whatever it is. So this method allows you to look at those high-level, higher hierarchical level issues. Okay, so can I see the more detailed model view of the model controllers? I'm hoping this is sufficient. I haven't got one any more detailed than this. This is just, well, in fact, I'll talk a little bit about this. So these sort of shaded areas at the bottom, and these grey arrows between the KLM Jet Centre, ground controller and runway controller, they're just to represent the physical hard standing running areas for the aircraft. So in the case of KLM Jet Centre, they are notionally in control of the ground movements on Kilo Apron and the parking position K12, which is where G Lear was at the start of the incident. Then as G Lear taxied, they moved from the Kilo Apron onto the taxiway, and so they became under the notional control of the ground controller. And then, as I said earlier on about boundaries between responsibilities and loss or uncoordination between controllers, when G Lear went from taxiway to runway 22, there was an implicit change in the control structure between the ground controller and the runway controller, but the actual control was via radio and wasn't enforced properly, and that's what caused the runway incursion, if you want a single root cause. been. Anyway, okay, so it will be more expected. The other issue that jumped out at me is the first officer was very experienced. An inexperienced first officer can lead to increased workload for the captain and thus easy to miss things. That's absolutely brilliant. Yes, it is. Right. So if you looked at the specifics of the two controllers, the control algorithm, as I mentioned, that defines how the controller behaves. And so if you have somebody who's relatively inexperienced and their controls and algorithm is not that mature, then the workload between them interacting with the aircraft captain means that the aircraft captain has to take on some of those implied control responsibilities and then feed back to the first officer the appropriate control actions. You know, so that's a very important but subtle aspect that can come out of this type of analysis with this level of detail. Okay, so Jenny, thank you. You're welcome, Jenny. Most appreciated. Floris, Simon, thank you for this webinar. I found it very interesting. Well, that's good. I hope so. Thanks for your time and effort. You're most appreciated. It's been a lot of time, a lot of effort. Shem, newer systems are coming in for controller pilot data communication that will aid this in the future. We are using it at quite a few airports, and it has been in place for quite some time for remote regions. Yes, that controller pilot data link communication technology, the text messaging aspects, I haven't included that in here because it wasn't part of the case study, but if you included that, what you've done is diversified the communication channels, but you've also introduced some new and potentially dangerous situations, either with control algorithms, mental models, interactions, or the unsafe control actions. So provided, not provided, wrong order, you know, late, early, too long, too short. So there are some quite insidious issues with that, which, you know, could, contribute to safety-related outcomes. Feedback in the control system is still not adequate. Pilots are supposed to read back all clearances, but they do not always do it, and sometimes, even with the readback, the error in understanding is not caught. Yes, that's absolutely right. Now, the reason that is because of the control algorithm and mental model of the ground controller and the aircraft captain. Now, you know, the ground controller says something which is not the same as their intention, and the person who hears that command, they may be expecting to hear something and hear the expectation, not what they actually received. And because both of those people are in that state, that, you know, that miscommunication will be missed. Now, there are, I don't know, in terms of an architectural perspective, there may be technical solutions to that. There may be a simple solution, might be somebody else sat on the outside listening to what's going on as a watch keeper. And I know that previously, and I was talking about Tenerife, so on the aircraft of old, they usually had a flight engineer, so you had a pilot and a co-pilot and a flight engineer. And those three controllers on the flight deck, because the flight engineer was not involved in the direct flight operations of the aircraft, they were almost a free safety feature because they could listen to what was going on and what was going on around them and almost have an independent view, a mental model of what was happening. And they could spot things such as that were going on and then put a control action into the pilot and co-pilot to prevent a dangerous situation developing. Now that organisation of three is a very interesting aspect of control structures, and I think that I'll talk a lot about that when I do finish off the Tenerife incident examination. Okay, so feedback in the control system, you know, we talked about that. Right, the issue you are talking about with incorrect communication has happened in the past, and there are regions where pilots are notified to be aware of it. South Korea and Asia come to mind. Yes. Okay, so we're near the end of the questions now, everybody. Does anybody else have any other questions before I crack these last couple? Maria, thank you for the presentation. You're most welcome. Mark, thanks. You're most welcome. Hi, thanks for the webinar. I think the intentional insecurity should differ from unintentional commands. When it is intentional, it could be by using guidelines, following procedures, but with intention of causing harm. So I really don't understand when we say regardless of safety or security issue. Right, sorry Nazar, maybe I wasn't that clear. So with the stamp-based approach, when you create the control structure, and particularly when you do STPA, so you're examining the control structure, you're looking at all possible circumstances and potential outcomes. Now, how those outcomes come about, whether it's a malicious intent or an unintended intent, doesn't really matter. You identify what are the unsafe control actions, and then you know what you need to do. You either have to do something about them and mitigate them, whether they're intentional or unintentional, or you have to architect your system to deal with those issues. So that's dealing with the control actions. Now, if you look at the causes of the control actions, the causal scenarios, some of those scenarios will be safety related, some will be security related, malicious, and then you look at, well, how do we prevent those? How do we engineer safety guided design? How do we prevent those? And that's where, you know, it doesn't really matter whether it's intentional or unintentional. It's actually how you control those aspects, how you mitigate those, that makes the difference. I don't know if that's very clear. It is getting quite long now. Thank you for the webinar, Yuri. You're most welcome. Many thanks for the presentation. Well presented and very interesting. Well, I hope so. I hope so. You're most welcome, Mark. Tassos, thanks for the excellent presentation. You're welcome. Good to see you on the webinar. NASA, thanks. You're most welcome. Okay, so I think that's all the questions. If there's anybody still here that would like to ask anything else, please ask now. Otherwise, I'm going to call it an evening because I've been going on for nearly 2 hours. Okay, well, I think we'll call that an evening. Thank you very much for attending. It's really appreciated. I hope that's been of value. If you do have any other questions or comments, please just get in touch. If you would like some help, I am available. You know, send me an email. I'll set up a meeting. We can have a chat. If you need me to get on a plane in the middle of the night because you're worried about something, just give me a shout. It will be a genuine pleasure. So thank you very much. Have a good night. Have a good weekend, and we'll see you on the next webinar. Thanks a lot. Bye-bye.